Hello everyone, I'm Jace Wolfe. I'm the Chief of Audiology and Research here at Hearts for Hearing. And I think what we'll do is give everybody about a minute to get in their places and everything and show up here, and then we'll get started. So thanks so much for being here today, and I'll look forward to chatting with you just in a bit. All right, well, thanks again so much for joining us today. Again, my name is Jace Wolfe, and I'm the Chief Audiology and Research Officer here at Hearts for Hearing. Welcome to our Facebook Live post to celebrate International Cochlear Implant Day. It's my privilege and honor to be with you here today. I love any chance that we get to celebrate cochlear implants. I've spent my entire adult life working with individuals who have benefited from cochlear implants. An amazing technology. I've seen it truly transform people's lives, and I think it's great that there's a day on the calendar that we can celebrate the types of opportunities that cochlear implant technology can create for individuals with severe to profound hearing loss. I also am very privileged to have the opportunity to interact with you guys today. If you have questions about cochlear implants, we would encourage you to submit those in the chat today, and I'll try to get to as many questions as we can today. And if we're unable to get to your question, then please go to our website and you can submit those there, and I'll be happy to try to follow up and answer your question later in time. So thanks again for your presence here today and for joining us and for celebrating International Cochlear Implant Day with us at Hearts for Hearing. The first question is a good one, pretty general question, but I think it's a great place to start, and that is, what's an elevator speech for how a cochlear implant works in complete layman's terms? And so, great question, and this one was submitted ahead of time, so it gave me an opportunity to have some props here to really try to give a better answer to that question. So, most people, when they think about deafness and they think about severe to profound hearing loss, they think about oftentimes nerve deafness. And even though that's a term that's commonly used to describe what happens with severe to profound hearing loss, it's not exactly correct. And typically what happens, and I'll just show you a model of the ear really quickly and how the ear works, and then we'll talk about how a cochlear implant works. But as you know, sound travels down the ear canal and it hits the eardrum here. And there are three tiny little bones that are attached to the eardrum. They're the smallest bones in the body. And when the eardrum vibrates, those bones vibrate as well, and they carry the sound vibrations to the cochlea. The cochlea is the inner ear. It's deep inside the head, and usually when we have hearing loss, that's where the damage occurs. That's where the dysfunction occurs. Inside the cochlea, there are tiny little hair cells, or tiny sensory cells called hair cells, and the job of the hair cells is to take the sound vibrations and convert those to a message that the brain can understand. And then the hair cells deliver those little messages to the hearing nerve and onto the brain. And typically, almost with all types of permanent hearing losses, it's those hair cells in the cochlea that aren't working like we want them to. They're not taking that sound message and stimulating the nerve. And so the way a cochlear implant works, it's fascinating that it works so well, is that there is a tiny little lead or wire that a surgeon threads into the cochlea, and the cochlear implant bypasses or takes over the function of the cochlea, and it stimulates the hearing nerve, the cochlear nerve, directly so that it can bypass the damaged hair cells and send the information that we need to hear onto the hearing nerve and then to the brain. And modern cochlear implant technology, it's absolutely amazing. There are two parts of today's systems. There's an external processor that you wear behind the ear or over the ear, and it has a little transmitting antenna on it that has a magnet in it. And the magnet of the external piece aligns with the magnet of the implant that's underneath the skin. And when the processor picks up sound, it digitizes that and sends it along this cable to the antenna. And the antenna sends a radio signal from the outside piece to the inside piece. That radio signal is picked up by the inside piece, it's digitized again, and then delivered down this little set of wires. And those wires are eventually kind of all wrapped up into one bundle of wires and again threaded into the cochlea, and it delivers tiny little electrical pulses to the hearing nerve so that it can respond and send that message up to the brain. So fascinating that it works so well. I can tell you from 20 years of experience working with cochlear implant recipients, I have adult patients who were completely deaf prior to their cochlear implant, and then afterwards they can carry on a conversation on the telephone, they can go to the movies or watch television without closed captioning, they can carry on conversations in restaurants. Truly unbelievable technology. We have children who are born deaf and they get a cochlear implant at a really early age, and they go off to their neighborhood kindergarten when they're 5 years of age, and they set the curve in that class. And some of the first patients I serve, and this makes me feel really old, but some of the first patients that I serve are now in college, or they're even graduating college, and many of those are going to college on full scholarships. They're knocking the cover off of the ACT or the SAT. One of my very first patients that I served is now in medical school. So the technology is amazing, and I think the thing I like about it the most is that it really removes some barriers that maybe existed in the past. Prior to working with cochlear implants, I would work with individuals who have severe to profound hearing loss, and they maybe were really frustrated that even though they got some benefit from hearing aids, they still couldn't talk on the phone, or they still couldn't watch television without closed captioning, or it might limit how they would converse with people, especially in challenging environments. And cochlear implants can really remove a lot of those barriers for a lot of individuals. So amazing, amazing technology. Another great question is that we filled it over our Facebook and in social media prior to the live event today is, what's the latest in news or updates to CI technology? Thankfully, there is a lot happening in this space, and this is kind of related to another question. What are the advancements in technology that have been made since the introduction of the cochlear implant? And my goodness, there have been huge advances. You can find still shots or even videos that show the very first people who received cochlear implants back when this technology was first developed back in the 70s. And you'll see that they're sitting in a big office, and there's a computer that's as large as the wall behind me, and they can only hear when they're in that office, believe it or not. And it takes a computer that big to be able to operate the cochlear implant. Of course, that was 40 plus years ago, so computer technology thankfully has evolved considerably in that time, and it's really miniaturized as well. Even in the 2 decades that I've been doing this, this is what I first worked with. This is a sound processor, still pretty large. My first patients had to use this in a backpack or a harness, or they clipped it to their belt, and there was a large cable that ran up to the piece that they wore on their head. Again, here's what we have today. The processor is really no larger than a hearing aid, and everything can be on the ear. It's run with a rechargeable battery, and it can last all day long with one charge. We also have devices that are single unit devices that are all contained in one unit, so there's nothing that you use on the head, and that can just be worn on the head real discreetly there. The microphone, the magnet, the processor, the transmitting antenna, all in one device. And so the technology has evolved so much, it just with the external processor that's worn on the head, really become much, much smaller, and it works a lot better as well. Over the last several years, the cochlear implant companies have worked really, really hard to develop technologies that help individuals with cochlear implants communicate much better or hear much better in the situations that give them or have given them the most difficulty historically. For instance, a lot of individuals with hearing loss will say, I have a really difficult time communicating in a really noisy restaurant where there's a lot of reverberation or echo. Today, we have microphones that can be worn a few inches away from the mouth. It can pick up the speaker's voice. It can focus on the speaker's voice and pick that out from over the background noise, and it can deliver it by radio signal straight to the cochlear implant. So the cochlear implant recipient can hear that individual's voice like they're right next to that person's mouth in that really noisy environment, even if they're sitting across from the table. Children can use these kind of devices as well if they're in the car, in a noisy car. The caregiver can wear this while they're driving and can communicate better with their child in the back seat in a car seat. Children use it in educational settings all the time, regardless of where the teacher is moving around the classroom. These devices can help the child hear a lot better, even if the classroom gets noisy as well. So noise management technologies, even within the processor, being able to recognize speech and noise and turn down the volume of the cochlear implant if the signal is primarily comprised of noise. Being able to focus more on sounds that come from the front and automatically do that if it gets noisy, assuming that more than likely the signal that the implant recipient is interested in hearing is coming from the front, and the noise is coming from other directions, so it focuses on sounds that come from the front and it turns down the noise from the sides and the back, and it can really help you hear better in a noisy situation and understand the person with whom you're trying to speak face to face in a noisy situation. So incredible advances in how we can allow people to hear in noisy situations. All implant companies on the market today have developed systems that allow for wireless streaming from a mobile phone device directly to your cochlear implant. So Apple iPhones or Android phones, some allow any Bluetooth device to stream directly to the cochlear implant. So if you're in the car and you have Bluetooth, you can connect to the system in the car and will stream that way. A Bluetooth enabled television or computer. So great advances in technology that allow you to hear better over the telephone or with the television, to stream directly if you're on social media or if you're watching a video over a phone or with an iPhone tablet. All implant systems allow for that to happen today. Also too, all implant systems have some type of a wireless remote control, either through the smartphone or a remote control that comes with the cochlear implant. That allows the caregiver of a child or an adult CI user to use that remote control to adjust the settings for a given environment, to turn it up, to turn it down, to increase the noise reduction, to change how the microphone works so that it focuses more so on speech that comes from the front or turns the noise down from behind a little more. It can allow you to adjust the balance. If you only want to hear what comes from a microphone or only want to hear what comes from a television because there's other noise in the room that's distracting, you can turn off the microphone on the CI processor and adjust and focus on the sound that's only being streamed wirelessly to the cochlear implant. So those are all great advances that have occurred in the technology. On the implant side itself, there have been great advances as well in a number of different areas. For one, the surgical technique has changed quite a bit over the last 5 or 10 plus years. When I started working with cochlear implant technology and individuals who have cochlear implants, many of the surgeons with whom I work, and I think they were pretty sincere when they would make this statement, they would say, well, the surgery is the easy part, and all the hard work comes after the fact with what the family does, or the recipient does, or the audiologist, or the speech-language pathologist. And everybody, we have to have all hands on deck. We all have to be working to optimize patient outcomes. But what we know now is that the surgery is really, really important. And there are great efforts that have been made with surgical processes and also with the design of the electrode or the little wire that goes into the cochlea to really reduce any trauma that happens inside the cochlea as that wire is inserted. And we have a number of patients we work with at Hearts for Hearing who have quite a bit of natural hearing. When they get their cochlear implant, maybe they can hear low pitch or bass notes really, really well, and they don't hear high pitch or treble sounds very well at all, and so it makes it really difficult. They can hear speech, but they don't understand it very well. And we have a lot of patients with that type of hearing loss who receive a cochlear implant, and they preserve most, if not all, of their hearing in the low pitch range, in that bass note range. So they still have their natural hearing. They can still hear many sounds without the cochlear implant, but they have better access to those high pitched sounds that really contribute to the clarity of speech. So protecting the cochlea, reducing trauma, getting that wire in the right place so that it can stimulate the nerve most effectively. Those are all efforts that have been made over the last decade or so that have really resulted in great improvement in the outcomes of individuals with cochlear implants. We've seen some evolution in how we determine candidacy for cochlear implants, who should qualify or receive a cochlear implant, who's most likely, if they receive a cochlear implant, for their quality of life to really improve and their hearing to really improve. And what I've seen over the course of my career is, when I first started, only people who were really deaf were considered as candidates for a cochlear implant. Otherwise, we would continue to stay with hearing aids. Nowadays, I see quite a few people who have quite a bit of hearing, but they're still really struggling. They can hear sounds, but still struggle to understand speech. We determined that through the testing that we do here in the clinic, that they would hear better, more than likely, with a cochlear implant. And so that's a big change as well, just in the services that are provided. Unfortunately, we know still though today that for every one person who has a cochlear implant, there are probably 19 to 20 who could benefit from a cochlear implant, whose lives would really be altered positively. It would improve their quality of life if they had a cochlear implant. So that's one great thing about the International Cochlear Implant Day, is that it gives us an opportunity to raise awareness about this technology and how it can benefit people's lives. And that's really a goal here at Hearts for Hearing, is to make sure that we can give access to these kind of opportunities to as many individuals with hearing loss that we serve. Another big change that has been really exciting that we've seen just over the last few years, when I first started, the earliest that a child could get a cochlear implant was 18 months of age. Shortly after that, it decreased to 12 months of age, so on their first birthday they could get a cochlear implant. Now we routinely see children get cochlear implants at 9 or even 6 months of age. It makes such a huge difference, and there's so much evidence in the research literature that shows us that the earlier we can provide good access to sound for a young baby born with severe to profound hearing loss, the better their outcomes are going to be later in life. And I've got a good friend, Shani Detman, in Australia, who has done a lot of work looking at the benefits of early implantation. And some of her research shows that if children get a cochlear implant prior to 1 year of age, when they enter into school at like 5 to 6 years of age, over 80% in one study of hers had age-appropriate listening and spoken language abilities. And so the benefits of providing early access to good intelligible speech, and to allow for the areas of the brain that process sound and develop listening and spoken language skills to really develop during those first formative 2 to 3 years of life, really pay huge dividends on down the line, and the benefits and the outcomes that we see for children with hearing loss. So going forward, I have a question. What type of advances do you see in the future? A lot of great questions talking about what we might see coming up, and do advances in the technology, would they even warrant maybe somebody having their implant removed in the future, because the advances are so great that the new technology would be so much better than the technology maybe that they received years ago. So what will we see coming down the pike? What kind of improvements? It's kind of hard to predict, but I think things that are probably natural to expect to occur over the next few years is that the size of the technology will continue to become smaller. They'll continue to incorporate more types of signal processing that will allow the implant to work better in noisy environments. And so that will be beneficial, because people will be able to hear better in classrooms and restaurants and those kind of places. I believe that they'll probably make processors that are more resistant to the wear and tear of daily life, processors that are completely waterproof that you can wear while you're swimming or running a marathon, or while you're in the shower if you wanted to, and you wouldn't have to be concerned about the water damaging the processor. Other advances, I think they'll continue to refine how processors work with consumer electronics. I do believe that they'll continue to give the end user more control over their listening experience. We have participated, one of my colleagues, Sarah Newman, has in particular participated in some studies that have looked at the possibility of giving the recipient, the cochlear implant user, control over the programming process. And so going forward, it might be that when you come into the clinic, the clinician will connect the cochlear implant to the programming computer, and then the listener, the cochlear implant user, will take control over the program or the development of the map that he or she will use to allow them to hear in certain situations. And I think eventually what we'll see happen is that will evolve even further to where recipients might be able to do that from the comfort of their own homes as well. And they will be able to connect their cochlear implant maybe initially to their computer at home, and maybe work with a clinician to work together to create a map from home, and then maybe eventually to use an app. There are, like I said earlier, apps on smartphones now that can be used as a remote control and can allow some adjustment to the maps that patients use, but I think we'll see expansion of that, so that you'll be able to maybe run tests to see how the cochlear implant is working, maybe be able to see how you're hearing with the cochlear implant through some tests that you can run from your smartphone, and then make adjustments to your cochlear implants to really optimize your overall hearing experience. One thing I know people are really interested in as a potential advance in technology, and another question that we had that I'll kind of will merge into this topic, is the topic or the potential of a totally implantable cochlear implant, where all we would have is the part that goes under the skin and is implanted. We would no longer have external processors, and I do think that's coming. It's difficult to predict exactly when that will come. I had a discussion 15 years ago with the head of one of the research departments of one of the cochlear implant companies, and she said, this is one of our primary interests, one of our primary goals or objectives is to develop a totally implantable cochlear implant, and I see this happening in the near future. And here we are 15 years later, and it's still not commercially available for people who might be interested in this technology. There are obstacles, there are barriers that we encounter when we try to use this technology. There have been a couple of small studies of people who have received totally implantable cochlear implants with a microphone underneath the skin. The microphone has a tendency for some recipients to pick up body noise or to not be able to pick up soft sounds as well, so your overall hearing experience is altered to a certain extent. Also too, if everything is totally implantable, right now with current cochlear implants, there's no power source, there's no battery in the cochlear implant. It's powered by the outside piece. The radio signal that sends the information over also sends the power over as well. If it's totally implantable, there will need to be a rechargeable battery inside the implant, and at night when you go to bed, you'll put a coil on the implant that will charge that battery, and that'll be a great thing, but just like with any rechargeable battery, as you've probably experienced with your mobile phone, over time the battery starts to lose its life, and there are totally implantable hearing devices on the market today, not cochlear implants, but middle ear implants that really kind of work more for people who are good hearing aid users. And those batteries and those devices have to be replaced every few years. And so that's another barrier or obstacle that we need to clear to determine how we can do that safely for individuals with cochlear implants, and how we can do that in a way that's not really intrusive to their day-to-day life. But with all that said, all the manufacturers are working on that technology. If you want to see what that technology might look like, you can get a glimpse of that if you go to the website of Envoy Esteem, E-N-V-O-Y, Esteem, E-S-T-E-E-M. They have a totally implantable hearing device that stimulates the middle ear. It's a technology that works well for people who can hear well with hearing aids, not to the point where they have severe to profound deafness and they need a cochlear implant. But Envoy also is working on a cochlear implant, and they have a breakthrough designation with the FDA, which is a designation that's designed to expedite the movement of a device toward commercial approval for clinical use. And so I think we're on the fast track to getting that kind of technology, and it is a priority for all individuals with severe or profound hearing loss to want something that is totally implantable. So I think more to come on that. As far as the implant technology itself is concerned inside, there's also some research that looks at how electrical stimulation can be delivered more efficiently or effectively to the nerve. We might see more precise delivery to the cochlear nerve to allow for clearer speech. There's some research that looks, instead of delivering electrical stimulation or electrical pulses to the cochlear nerve, maybe using optical stimulation or light to stimulate the nerve. Light would be much more precise and potentially could provide a clearer signal as well. Those things are probably a little further out as well. There are some barriers technically with that as well, but that might be something that we see coming down the pike as well. With all that said, what does that mean as far as when I ever need to get my cochlear implant replaced? That's a great question, and it's a complex question. I will tell you personally, I have served cochlear implant recipients for 20 years, some who have had their implant for over 20 years, and they're still doing really, really well with that cochlear implant. And some of those individuals, they received an implant 20 years ago, and then many years later they got a cochlear implant on the other ear. And oftentimes, because of the greater duration of deafness on the second side, they hear better with their first ear, and they would never dream of replacing that first ear with newer technology, because they hear better with the older technology than they do with the newer technology. So I have yet to see a patient replace their older implant technology just because they want to upgrade to the new technology to hear better. A couple of comments on that. One thing that's great is that the cochlear implant companies have done a great job of allowing implant recipients who have had their implants for decades to be able to upgrade to the newest outside processors. So even though their implant inside might be 20 or 25 years old, they can still use the newest sound processors and take advantage of all the advances that have occurred with that new technology, so their hearing still continues to improve over time. Another comment on that is that I do have a friend who works at the University of Miami. She's an audiologist, and she has worked with some patients who have really old devices, 20 plus years, and they have elected to replace those devices, and their experience has been really, really favorable. They've maybe took a little while to adjust to that new device, but once they got over that adjustment process, they heard at least as well, if not better, with that newer technology. So, and that's probably a big part of it. Your brain really gets accustomed to one type of stimulation from the cochlear implant. When you get the new technology, it's a different type of stimulation, so it just takes the brain a while to acclimate to that new technology. But in most cases, when we replace cochlear implants, the outcome, the result is really, really favorable, and patients do at least as well, if not better. That is related to another question that we came through: is do cochlear implants, do they ever need to be removed? Does the magnet need to be removed? Does the implant itself need to be removed? The answers to those questions are yes, but it's very uncommon. If you look at the reliability of the inside piece, and if you look at after several years of use, typically around 99%, sometimes a little higher, are still in use. And so it's a very durable device. It's very, very well made. They're very reliable. They rarely have to be replaced because they malfunction. It happens, but it's very uncommon. They're made from materials that are biocompatible, from titanium and silicone, so the same types of materials that are commonly used in implantable devices for orthopedics or for other types of implants like pacemakers or cosmetic devices. So they work really well on the body. It's extremely rare for them to be rejected. The question about the magnet, There is a magnet inside the cochlear implant. Years ago, it presented some issues if somebody had to get an MRI because the strong magnetic field of the MRI could damage the magnet or the implant, or it could be uncomfortable for the user. The magnetic technology evolved over time to the point where it could be left in place, but it could be bandaged into place, and the individual could still have an MRI. If necessary, on the older implants, in the silicone there is a little slit, and the magnet can be popped out if needed for the MRI to be completed and then replaced. But the best news is that over the past several years, all of the implant manufacturers have developed magnets that can be left in place during MRIs. And so going forward, there's no need for that. There's no threat of it being uncomfortable or of damaging the implant during an MRI. The only concern would be is that the magnet creates a small shadow around the implant site. So if that device, if that part of the head needed to be imaged with an MRI, it might be difficult to do so, but again, that would be a pretty uncommon occurrence. And so typically, when you get an implant, you're going to have it for many, many years, and the technology will advance on the outside to allow you to continue to hear well for many, many years. The implant companies, they really make a concerted effort to try to develop technology that will last for a lifetime. They know that they're making a commitment to the recipients for a lifetime, and so they've really gone to great lengths and efforts to develop this technology so that it'll work well for long periods of time without the need for replacement. So that brings us to 30 minutes, and like I said, I appreciate so much your presence here today, and I appreciate so much the opportunity to celebrate cochlear implants on International Cochlear Implant Day. And I really want to make sure that we are able to answer any questions that you might have. So if I didn't get to your question, please go to our website or to our social media sites. You can find us on Facebook and Twitter and Instagram, and reissue that question, and I will connect to you directly to answer that. So thanks again for your presence here today. I really appreciate it, and happy International Cochlear Implant Day to you. Goodbye.